Welcome humans. Before we get on with question 2, we have had a suggestion for our mascot in the comments of Pedro. I've looked up the Latin. Pedro comes from the word rock or stone, so that might come in useful for some of our physics questions, but also hopefully Pedro will be your rock to navigate you through your GCSEs. Alright, on with question 2 now. There's a couple of questions here that require recall of equations, which obviously in 2023 you won't be doing because you'll have equation lists, but let's go through them anyway. So question 2, A is a multiple choice, and you basically have to select the correct equation for work done. So work done, so how much energy used to move something with a force. So we apply a force to something and we move it over a certain distance, and we move it in a distance in the direction of the force. We multiply those two together and that gives us work done. So that is part 1. Next we have an equation that we need to solve here. It says a ball, but let's use a mini model of Pedro. We'll get rid of his arms and legs for the moment. Hope he doesn't mind too much. So we're saying it must be a mini Pedro because it doesn't weigh very much, 0.46 kilograms. And Pedro is going to be lifted through a height, a vertical height of 2.05 meters. We're given the equation this time, so change delta, that symbol you might know from maths, is change in GPE. If you're ever wondering at GCSE, it will always be a change in gravitational potential energy that you're working out. It's mass times the gravitational field strength times the change again in height. Now we've got to substitute in, but there is a bit of knowledge that you need to have here, which is that G, gravitational field strength, is 10. So we've got 0.046 multiplied by 10 multiplied by 2.05. Let me make that look a bit more like a 5. There we go. Let's get the calculator out. I haven't got the visuals very well done on that. I'm still learning. There we go, that'll do. So 0.046 times 10 times 2.05, and we're going to give us 0.943, but I'm going to leave it to 2 significant figures because we've got 2 significant figures here. We do have 3 here, but we're going to leave it to 2 because that's the smallest number. But just so you're aware, you would only lose marks on that on specific questions that state that you need to leave it to a certain number of significant figures. But I'm going to get us into good practice. So 2 significant figures, 0.94. Right. Next question. So that was B part 1. Let's look at part 2. And here we're saying the ball is released. So Pedro is not going to be quite as happy in this case as he is dropped. So he is going to fall, and at some point in this fall he's going to have a velocity equal to 3.5 meters per second. And we need to calculate the kinetic energy. So what is the kinetic energy? Now in this particular question it would have originally been recall this equation, but you will be given this equation. They like it, it comes up a lot. It's half mass times velocity squared. Now just be careful, lots of people lose marks for not putting the square in or forgetting to square the velocity. So let's put that in, 0.5, and then it's using the same mass as before because it's the same ball or the same Pedro, 3.5 squared. So let's just pop all that in, squared, all of that, and that's going to give us this. And again I'm going to leave it to 2 significant figures, so 0.28 joules. Joules I think is given in both of those, or I should have said so. That was a 2-mark question, I think, because you're given the equation. This was a 3-mark question because you had to recall it. Although, as I say, in 2023 you won't have to recall it. Okay, moving on to the next part. we are told that the ball bounces several times. I'm just going to sketch a quick graph. I'm going to get you to use your papers to do the precise measurement, but essentially what we've got is the idea that the ball will fall, it will bounce, so this is time going this way, it will bounce, and when it bounces up it will not bounce up to the same height that it went to before. Each time it is bouncing less high. We'll look at why in the next question. So this is the height. And what you need to do is read off this point here on your graph, so where the ball bounces up to, and you need to take a measurement here. Pause if you need to do that, or if you've already done that. Any value between 0.8 meters and 0.95 meters should be fine. You want to be as precise as you can in any question where you're reading off a graph, but there is usually a bit of a range, there's usually a bit of leeway, but don't go too far. Don't just look at anything, oh that's 1. That won't be good enough. In this case you would lose the mark, and that is just for 1 mark. And then finally, for 2 marks, we need to explain why the ball does not bounce back. So why does a ball falling not come back to the original height? Well, now kind of makes common sense, but why is that? Well, because energy is lost. Let's put the right part in, part 4. Energy is lost to the surroundings. Energy is lost to the surroundings. Now actually that should get you both marks most of the time in GCSE questions, but I would always just to make sure, I would give an example of how it's lost. So maybe energy is lost to the surroundings, thermal energy lost when the ball bounces, and then you're definitely very happily going to get both marks. But you could talk about energy lost to sound energy, or the bounce not being efficient, various things you could say about how energy is lost. Right, that is question 2. I will move on to the next question.